Hi everyone, welcome back to my channel, Numerics with Nadia. In today's lesson, we're going to continue learning some pre-algebra topics, and specifically, we're going to go through the powers of 10. So to start out, I'm going to write out some of our lesson objectives. We're first off going to do an introduction to the powers of 10, and then our second objective is going to be to use exponents with powers of 10. And then lastly, we're just going to do some practice problems. So to start off, let's introduce what the powers of 10 are. The way that we'll define the powers of 10 is the powers of 10 are a special type of exponent with a base of 10. So for those of you who don't really have too much experience with exponents, we'll do a very clear job of defining what the base is here, but we'll also do some more in-depth videos of exponents later on. Powers of 10 is just like a preliminary first look at exponents and bases. So to start off, if I had 10, the base would be 10, and there isn't really an exponent there, but technically it's 1. What if I had something like 10 times 10? Well, 10 is our base, and we have 2 of them, so that would be 10 to the power of 2, or 10 squared. The same pattern continues if I have 3 10s. 10 is our base, we have 3 of them, so it would be 10 cubed. So now the left-hand side with the 10s being expanded out by multiplying, right? 10 times 10 times 10. Those would all be referred to as standard notation. And then the right-hand side, well, that is with our bases and our exponents, right? So the 10 squared, the 10 cubed, and the 10 to the power of 1, those would all be referred to as exponential notation. We're going to distinguish those now because in our practice problems later, we're going to be going in between both forms. Now, an important note is that if you look at the left-hand side and the right-hand side and then how we worked our way down, we notice that the larger the exponent, the larger the number. So if we look in standard notation, we have the 10s being expanded out by multiplication, right? So let's compare 10 times 10 to 10 times 10 times 10, right? 10 times 10 is 10 squared. 10 times 10 would be 100. And then if we compare that to 10 cubed, well, 10 times 10 times 10 is 1,000. So obviously 10 cubed would be greater than 10 squared. And now that we've made that distinction, it's a really important note. So we'll get into our practice problems now. So like I always say, reading the directions is the most important part of the question. We want to know what we're looking for. We're going to have a few different types of questions in our practice for today. First set of practice problems, our directions say to circle the larger amount. And this is going to align with the important note that we just distinguished. So for number 1, we have 10 to the 5th, and we're going to compare that to 10 to the 8th. We know that the larger amount is the one with the larger exponent, and we know that 8 is greater than 5, right? So the larger amount would be 10 to the 8th for number 1. And for number 2, we have 10 to the 13th. We're going to compare that to 10 cubed. We know that 13 is greater than 3, right? So we know that 10 to the 13th would be the larger amount for number 2. Now for number 3, we have 10 to the 11th. We're going to compare that to 10 to the 16th. Now we're going to look at the exponents. 16 is greater than 11, so we know that 10 to the 16th would be the larger amount for number 3. So now that we've done this type of question, we're going to get into another set of questions now. And we will start out, like always, by reading our new set of directions. So for these problems, the directions say to find the values of the following powers of 10. So that means that we're going to be given everything in exponential form, right, with our base of 10. And then depending on the exponent, we're going to evaluate and expand from exponential form into standard form and then multiply out to get our numbers. So to start off for number 1, we have 10 squared. So the 2 means that we have 2 tens, right? Because 10 is our base. So that means 2 squared, if we expand it out, is the same as 10 times 10. And we know that 10 times 10 is 100, but the trick I'll show you guys is we'll write our 1 and then the number of zeros, so each 10 has 1 zeros, we would write 2 zeros at the end of the 1. So 10 times 10 gives us 100. As our exponents get bigger, it'll get more difficult, so that's why that little zero trick helps us out. So for number 2, we have 10 to the 4th. That means that we would have 4 tens being multiplied together, right? And just using that shortcut, we'll write our 1, and we have 1, 2, 3, 4 zeros, so we'll write those 4 zeros in. The 4 zeros match up, and we know that 10 times 10 times 10 gives us 10,000. Now for number 3, we have 10 cubed. So this one, our base is still 10, but our exponent is 3, so that means that we would multiply that 10 out 3 times. So we get 10 times 10 times 10. Using the same zero trick, we will write our 1, and we have 3 zeros to fill in, so we'll write those 1, 2, 3 zeros, and 10 cubed will give us 1,000. Our last practice problem for this section will be number 4. And for number 4, we're given 10 to the 5th. So this is our largest one. 10 to the 5th means we are multiplying that base of 10 out by 5 because 5 is our exponent. So we're going to multiply that 10 out 5 times. 10 times 10 times 10 times 10 times 10. We're going to have 5 zeros after doing that, right, from each 10. So we'll write our 1, we'll write out the 1, 2, 3, 4, 5 zeros. We'll plug in our comma, and for number 4, we will get 100,000 for our answer. All right, you guys, now we're moving on to our last set of practice problems. For this set, the directions say to write the following in exponential form. So in our last set of practice questions, we went from exponential form to standard form, and now we're going to go from standard form to exponential form. It's a little bit of a reverse of what we just did. So for number 1, we have 100, and now there's 2 ways that we can think about this. First, we can think of how many tens go into 100. Whatever amount of tens, we would write our base of 10 and then our exponent. And for this one, it's pretty straightforward. We know that 10 times 10 gives us 100. So we know that that would be 2 tens, right? So our base would be 10, our exponent would be 2. The other way is to use the zero method. So we're going to look. After our 1, we have 2 zeros. So that is it. We'll just write our 10, and we know our exponent is 2 because there are 2 zeros. Now we'll get into our second example for this portion. For number 2, we're given 100,000. Now for this one, it might be a little bit harder to see how many times 10 goes into 100,000, so we can use the zero method. After the 1, we have 5 zeros, so 100,000 would be equal to 10 to the 5th. Now we'll move on to number 3. For number 3, we have 1,000. Now for the 1,000, we know the base is 10. We have 3 zeros after that 1, so 1,000 would just be 10 cubed. And now for our last one, we have 1 million for number 4. Now this 1 million, we know the base is still 10. We're going to count up all the zeros, and we have 6 zeros. So 1 million is equivalent to 10 to the 6th. All right, you guys, and that wraps up all of our practice questions for today. Thank you for sticking with me. I know that we had a lot of practice questions, 3 different sets of directions, but I hope you guys enjoyed this video. Thank you guys so much for watching. Please be sure to like and comment any other videos you'd like to see. Subscribe if you haven't already, and I will see you guys next time.